So this is part 2 of going over the practice midterm. So let's go ahead and get started. So question 4 here says we want to write an equation of a line passing through the following pairs of points. Okay, so let's first start by remembering what is the basic form of a line, or in this case, we want to think of the slope-intercept form of a line. So this is given by y is equal to mx plus b, where m is the slope and b is the y-intercept. Okay, so b is the y-intercept. Okay, so let's go ahead and see if we can find an equation of these different lines. Okay, so if all we're given is 2 pairs of points, we are able to find the slope of a line. Okay, so we can think of remember the slope is given by m is equal to rise over run, or we can think of this as y2 minus y1 over x2 minus x1. Okay, so to find this, let's go ahead and assign which one of these points is point 1 and which one is point 2. We'll say that this is point 1 and this is point 2. Okay, so this is going to be x1, y1, x2, y2. Okay, so now we can find the slope. So in this case, this is going to be given by -3 minus -5 over 3 minus 1. Okay, -3 minus -5, this is the same thing as -3 plus 5 over 2, or we have 2 over 2, which is 1. So our slope is 1. So here we have when the general form of our line is going to be y equals x plus b. And the reason it's just x is because of this 1 here. Okay, so we have y equals x plus b. Okay, so now we can find b by taking either of these points and plugging them in to see what we get. Okay, so let's go ahead and plug in, I'll say point 2 here. Okay, so we can plug in the x and the y values for point 2. So that's going to give us -3 is equal to 3 plus b. Okay, so we can take 3 away from both sides, and we get b is equal to -6. So the full equation for our line is going to be y equals x minus 6. Okay, now let's look at this set of points. Here we have 2 and 4 and 2 and 7. Okay, 0.24 and the 0.27. So what we want to notice here is that they have the same x values. Okay, so if you see a point, if you see 2 sets of points that have the same x value but different y values, you know that all you have to do is write the equation x equals whatever that number is. Okay, x equals 2. You can go about it the other way here, but it's certainly enough to say x equals 2. Okay, they have the same x value. Okay, so x equals 2 would be the solution here. And very similarly here for this set of points as well, we have 2, 9, and 6, 9. They have the same y values, so we're going to say that y equals 9 is the equation for our line. Okay, let's take a look at this one. We're going to consider the line y equals 7 over 2x plus 1. We want to find the equation of the line that is parallel to this line and passes through the point -6, 2. Okay, so if we want to find a line that is parallel to this line, we know that parallel equals the same slope. Okay, so we have the same slope for a parallel line. So if we have a parallel line, it's going to have the same slope as your original line. Okay, so we know that. So that means that if we have a parallel line here, it's going to have the form y equals 7 over 2x plus b. We don't know what b is going to be yet because we can't deduce anything about the b value just from the fact that it's parallel. That's where we're going to have to use this point. So we have the point negative 6, 2, and just like we did for the previous question, we can take the point negative 6, 2 and plug it into this line and figure out what b is. So we can take the y value, which is 2, and the x value, which is negative 6, and plug them in here. So we have 2 is equal to 7 over 2 times negative 6 plus b. Okay, 7 over 2 times negative 6. Negative 6 divided by 2, that is negative 3. So we have 2 is equal to 7 times negative 3 plus b. Or we have 2 is equal to negative 21 plus b. Okay, so we can add 21 to both sides, and we get b is equal to 23. Therefore, our equation is going to be y equals 7 over 2x plus 23. Okay, how about the equation of a line which is perpendicular to this line and passes through the point negative 6, 2. So if a line is perpendicular, okay, if we have an original slope of a over b, okay, the perpendicular slope is going to be negative b over a. Okay, so the original slope of a over b implies a perpendicular slope is going to be negative b over a. So what you do is you flip the fraction and you change its sign. Okay, or if you just have an integer value, say a slope m, it would be negative 1 over m. So you're finding the reciprocal and you're changing its sign. So the original slope was 7 over 2. Okay, this is our original slope. Okay, and so now we're going to have negative 2 over 7. So the basic form of our line is going to be negative 2 over 7x plus b. And exactly the same as we did before, now we can plug in the point negative 6, 2. So we're going to have 2 is equal to negative 2 over 7 times negative 6 plus b, or 2 is equal to 12 over 7 plus b, and that's about as much as you're going to simplify that one. So let's solve for b. So we have minus 12 over 7. Okay, and then what we're going to do here is we're going to say b is equal to 2 minus 12 over 7. And let's see if we can rewrite 2 so that it has a denominator of 7. Well, 14 over 7 is 2. So this is the same thing as 14 over 7 minus 12 over 7. So we end up with 2 over 7. So the actual answer here is going to be y equals negative 2 over 7 x plus b, and b is 2 over 7, so we have plus 2 over 7. Okay, for this one, we want to solve the following 2x2 systems of linear equations. Okay, so this first one here, we have x minus 3y equals negative 19, and negative 5x plus 4y equals 40. Okay, so this is like a pretty good candidate for doing a substitution method. So let's go ahead and solve for x here. So we can add 3y to both sides, and this is going to become x is equal to 3y minus 19. And what we can do is we can take this x here and substitute it in right here. So that's going to give us negative 5 times 3y minus 19 plus 4y is equal to 40. Okay, so now what you'll notice is we have an equation that just has the y variable, so we can very easily solve for the y variable. But so to do that, let's go ahead and distribute this negative 5. So we'll have, this is going to become negative 15y. Okay, we have negative 5 times 19. That's going to give us positive 95. Then we have plus 4y equals 40. So negative 15y plus 4y, that's going to give us negative 11y plus 95 equals 40. So we can take 95 away. All right, and that's going to give us negative 11y is equal to negative 55. We can divide both sides by negative 11, and we get that y is equal to 5. Okay, but now that we have y is equal to 5, we can take this and plug it back into either of these two original equations to get our answer. Or we can even plug it back into x equals 3y minus 19. Perhaps that would be the easiest way to do it here. So we have, since it's already solved for x, that'd be the way to do it. So we have x is equal to 3 times 5 minus 19, or 15 minus 19, which is equal to negative 4. So x equals negative 4, and y equals 5. These are our two values we're looking for here. Okay, how about this one? Here we have negative 9x plus 5y equals negative 18, and 6x plus 7y equals 12. Okay, well, let's see what we can do here. All right, so I'm thinking we can go with to try to eliminate the x's here. We're going to have to do some basic multiplication to make this happen. So let's go ahead and multiply this equation here by 6, and we're going to multiply this equation here by 9. And that's going to allow us to get a common number here for the x coefficient. Okay, so if we do this equation here by 6, we'll get negative 54x plus 30y. Okay, then we'll have that is equal to negative 108. And then here we'll have positive 54x, okay, plus 63y. And then we have 9 times 12, which is 108. Okay, so 54x and negative 54x, if we add these two together, that's going to be 0. And then we have 30y plus 63y. That's going to give us 93y. Okay, and this is equal to 0. Okay, so now we can divide both sides by 93, and we get this is equal to 0. Y equals 0. Okay. So if y is equal to 0, we can take that value and we can plug it into either of these equations here. So let's plug it into the second one. So we have 6x plus 7 times 0 is equal to 12. Okay, so 7 times 0 is 0, so we have 6x is equal to 12. Divide both sides by 6, and we get x is equal to 2. So we have x equals 2 and y equals 0. And you could solve for one of these and do a substitution if you'd like, but I think the easiest way here is to do, to go about that in this way. Okay, so now let's try this one. Here we have 4x plus y equals 8, and negative 4x minus y equals 8. Okay, so let's go ahead and do a basic addition here. So if we do that, we can do negative 4x and 4x. That's going to give us a 0. Y and negative y equals 0. 8 plus 8 is 16. Okay, sweet. So if we do that, that gives us 0 is equal to 16. So we would actually say that these two are inconsistent. So anytime you try to simplify this by any of these methods and you get something that is nonsense, like 0 equals 16, we say that these two equations are inconsistent.